Alright, so in this video we're going to take a look at how to measure RMS voltage or RMS value of a sine wave. We kind of previously looked at how to do that for an average value of a signal. I have some metrics up here that we can use just for a sanity check to make sure that our values are correct. We're going to start with a signal that's a sinusoid with a peak value of 169.7 volts. That might seem oddly specific, but the reason is that that's kind of the wall power that you have coming out of your outlet. Anywhere that you probe, if you wanted to probe that, you could. Definitely wouldn't recommend doing that unless you know what you're doing. But that is the city power that we have provided to us at any building where you have an outlet, your home, etc. is this signal right here at 60 hertz. Okay, so it has a peak value of 169.7 volts. If we multiply that, oh, sorry, I think I said multiply. It's supposed to be divided by the square root of 2. If we divide that by the square root of 2, we get 120 volts RMS. And that's the RMS value. That's when you look at your adapter and it says 120 volts. It's talking about that RMS voltage. So let's take a look at the RMS voltage measurement in LT Spice, which we already figured out how to do by hand, but now we're going to go ahead and show how to figure that out in Spice. We already looked at it last video a little bit. There's one way to find it through the graph, but we can also find it using the Spice directives. So let's go ahead and call this V sine. Just make a sinusoidal signal here. I'm just going to call this, a 0 volt offset. We'll give it an amplitude of 169.7, and then our frequency, we're just going to make it 60 hertz because that's just going to represent our city frequency, city power that we have coming to our outlet. All right, and so what I'll do is I'll run for, let's just actually parameterize the frequency here. Let's say dot param f equals 60. I'll give myself a parameter for the period, which is 1 over f, of course. And then instead of saying 60 here, I'll just say f. And what this allows me to do is it allows me to run my transient for a particular number of periods. Let's just do 3 periods at 60 hertz. Okay. And then when we run, of course, we expect to see 120 for the RMS value. Let's just blow this up. All right, that's good enough. And then when I come over here and plot this sinusoid, I can go right up top, left control, and then left click on my sine, and I get 120 volts RMS, which is exactly what I expected to see. Okay? And so what that means is that I have 120 volt RMS, which of course means that the average, if I were to connect this signal to a load, this signal would send and that load would dissipate the same amount of average power that would be dissipated if I just connected it to a 120 volt DC source, right? That's the definition of RMS. Basically tells us the DC value, 120 volts, that would supply the same average power to a load as this AC source is supplying, okay? And so that's one way to measure it, is to just come in here and control left click and I see the 120 volts. Another way to measure it, very similar to what we did in the last video, let me move this over a little bit, is to come in here and do a Spice directive where again I say dot measure, or MEAS. I name my measurement, so let's call it V sine underscore RMS. The type of measurement, which in this case is RMS, so we use capital RMS, and then what am I taking the RMS of? I'm taking it of the voltage at node V sine, okay? V of V sine. So I hit OK. I plop that down in my schematic. I hit run, nothing changes, but if I hit Command L now, I see this measurement for my RMS, which is 119.996 over the span of 50 milliseconds. That's pretty great. That gives me almost exactly 120 volts, which is what I expect for my RMS, okay? So that's how we figured out how to find the average value of a signal in Spice. Now we have the tools to find the RMS value of a signal in LT Spice, so we're rolling. All right, so I'm gonna go ahead and end this video here, and we'll see you guys in the next video.